Hey there, pre-calc. All right, here's the do now. Let's have you hit pause while you figure out how to expand each of those logs. And then once you got your answers, resume the video. I'll just wait. All right. Hey, so we'll expand those. Scroll down here so we can actually read all of them. So for A, it's multiplication, just break it apart into adding. B, it was division, so we break that apart into subtracting the two separate logs. And for C, pretty similar to A with the addition of some exponents. So 2 gets, that exponent gets multiplied times log base b of x, and the 6 gets multiplied onto the log base b of y. And then B and D also pretty similar with the exception of exponents. And so again, it'll be a subtraction of 2 logs, but we'll put the 6 log base b of x minus 2 times log base b of y. And then let's give you a chance to see all of them together. Right. So today, continuing to our study of logarithms, expanding and condensing, we're just going to look, there are not any more ways to expand and condense. We're just going to look at some more tricky problems and start getting into a little bit of application even. So you've already seen this. It's in your notes already. If it's not in your notes, it needs to be in your notes. We're going to use all 3 of these, expanding, condensing. There are not any other ways that we deal with logarithms. Like that's it, right? It's not like there's more. So here's some examples. This one probably could skip, is pretty straightforward, but we're going to do it all the same. So combine 3 separate logarithms into the single logarithm. We could just say condense. That means. And so the 14 is going to come over here as an exponent. The 11 is going to come over here as an exponent. The 4 is going to come over here as an exponent. The first 2 I'm adding together, so it's going to be multiplication in my new log. And then the last 2 are subtracting, and so the last one is going to get divided in my new log. Let's see if we can do this all together at the same time. Log of, I'm going to get a big set of brackets here, and hopefully everything will fit. I can see there's subtraction, so there's going to be, in here, there's going to be division. All right, so I'm just going to start with my fraction line. So x to the power of 14 from the green part there, and then that's being added with the next part here in blue. So this is going to be on the top also. If I'm adding the separate logs, it's going to get multiplied together. They'll both be on the top of this fraction line here because they're getting multiplied. The only reason the fraction line is there is for this last bit, minus 4 log of z. So down at the bottom, it's going to be divided by z to the power of 4. And then this is way too big. I don't actually need it to be that big. I'm going to get this bracket to move. The bracket is stuck in place. Well, that's all right. Circle this with smiley faces and we'll be done. All right, yay. All right, up next, the same idea, but with natural log. So ln just means log base e, does not change anything. The base doesn't change anything about how we expand or condense. So I got natural log of 6 plus 5 times natural log of x plus 4 times natural log of x squared plus 2. All right, well, in this case, there are 3 separate logs. They're all being added. So when I condense them, I'm just going to multiply all that stuff together. This one will be in red. This one, I got a 5, so that is going to condense. The 5 will turn into the exponent on the x. And the 4 here is going to turn into the exponent on that whole entire set of parentheses. So natural log of 6 times x to the power of 5 times x squared plus 2, close parentheses, the whole set of parentheses to the power of 4. And then we do not need to multiply or distribute all that stuff together. I mean, if you wanted to, you certainly could. This is going to be really, really hard because we're going to have to do the blue part first, x squared plus 2 to the power of 4. That means the whole set of parentheses multiplied by another whole set of parentheses, multiplied by another whole set of parentheses, and another whole set of parentheses. That's going to take a really long time. I don't want to do that. You do not have to do that. It is not expected of you. Don't. don't. There's your final answer. All right, here's up next. So 4 parts. Look closely. Recognize some problems from the do now. Okay, so here is an important difference. This is telling us that log base b of x equals 10. Okay, I don't know what x is. I don't know what b is. I don't know the base or the output. But I know that the log is 10. Basically, it's giving me a tiny little bit of a log table and saying, here, go use the logs to evaluate some stuff. Okay, so for part A, log base b of x times y. I don't know what x is, and I don't know what y is. I know they're logs, but I don't know what x and y are. So I can't just multiply them together. The only thing I can do is expand log base b of x times y. And so I could turn that, sorry, I gotta choose my colors. All right, so I can turn that into log base b of x plus log, base b of y. All right, so there it's expanded. And then log base b of x, that's 10. It tells me that. Plus, and here log base b of y, that's 6. It tells me that log base b of y is 6. So if I expand now, I can use those 2 facts that it told me to begin with, the 10 and the 6. So 10 plus 6, 16. Final answer. How about B? All right, kind of similar, except I'm going to expand. This is division, x divided by y, so it's going to expand and turn into multiplication. It's going to turn into subtraction. So log base b of x minus log base b of y. Log base b of x, that's 10. And log base b of y, that's 6. This time I'm subtracting. 10 minus 6 is 4. C. All right, a little bit more. I mean, we've seen this because this is part of the do now. So when I expand, I know that the little exponents are going to turn into multiplication. Let's see if I can get myself enough space to actually do this problem. So let's go like this. Shoop, shoop. I'm going to do C right over here. We'll do D in a second right there. So expand to C. We did that already. Okay, that was part of the do now. So 2 times log base b of x plus 6 times log base b of y. All right, well, log base b of x, that's 10, but I have to multiply the 10 times 2 because it says 2 times log base b of x. So here's 10, but it needs to be multiplied by 2, 2 times 10. Then add 6 times log base b of y, that was 6, so I have to multiply the 2 and the 10, I have to multiply the 6 and the 6, then I can add them together. So 2 times 10 is 20, 6 times 6 is 36, 56. Final answer for C right there. All right, not so bad. D. So I got the same idea here. We already expanded 6 times log base b of x minus 2 times log base b of y. Log base b of x, that's 10. So I have to do 6 times 10, subtract 2 times, and log base b of y, that is 6. So 6 times 10 is 60, and 2 times 6 is 12. 60 minus 12, negative 48. Final answer for D. All right. One last one. Okay, also parts A through D. There's an important difference. It looks like it's the same, right? Because it starts off by telling us the log base b, log base b of x, that's 3, and log base b of y, that's 12. So it's going to give us different values, and you think, okay, it's just a different problem. There's an important difference here. Let's look at part A first. Okay, so expand. All right, so I've got log base b of b times x divided by y. So I can just expand log base b of b plus log base b of x, and then subtract log base b of y. Okay, so log base b of x, that's 3 now. Log base b of y, that's 12 this time. Subtracting. What about this part? I don't know what log base b of b is. It didn't tell me that. What? Okay, don't panic. Log base b of b. We know this. I mean, it doesn't seem like we know it, but actually we do. So remember, every time we see the word log, it means power, right? So power. What power would we have to put on this little b to get an answer of b? All right, we could write this over here. B raised to some power needs to give us an answer of b. Well, what power would do that? 1, right? Anything to the first power just equals itself. So n equals 1. So this blue part does not like tell us in the directions. Log base b of b is whatever. That's 1. Now, 1 plus 3, that's 4. Minus 12 is going to give me negative 8. Okay. How about b? We'll do that right here. Okay, so again, expand first, and then we can work on what comes next after that. So log base b of x minus, so there's two things that are down in the bottom of the division. It's log base b of x divided by b times y. Okay, so be careful. So this is going to be log base b of x minus both of them, but we're going to do one at a time. So log base b of b, and then minus again, because the y also is being divided. This part of the bottom as the original problem. So log base b of y. Okay, this one, and my colors right. Yeah, that one is 3. Minus, all right, let's look at log base b of b again. The right color, there we go. So that's 1 still, because b to what power is going to equal b, right? Well, as long as the base and the output are the same, it's going to equal 1. And then I'm going to subtract log base b of y, and that was 12. All right. So 3 minus 1, that's 2. And then subtract 12, so it's going to be negative 10. Okay. Let's see if I can get some space down here. Beep, beep. I'll do C, and then in a second we'll get to D over there. I'll probably need, I don't know how much space they're going to need. Probably not that much, but anyway, C first. Okay, so log base b of b times the square root of x. Okay, so I'm going to just expand this all at once. So I got log base b of b. Okay, so inside the original one, it was b times the square root of x. I know that's going to expand to addition. And then square root, it's like an exponent. So I could have written this right here as x to the power of 1/2 instead. And then that exponent is going to go, when I expand, is going to go in front as multiplying by 1/2. Okay, so log base b of b plus 1/2 times log base b of x. And my colors, so log base b of b, that is 1. Anytime these are the same, it's going to equal 1 plus 1/2 multiplied by, this is red, log base b of x, that was 3. Because we're going to have to, order of operations, we'll have to multiply first. 1/2 times 3, that's 1.5. And then add the 1. 1 plus 1.5 is 2.5. 2.5 decimals, we're fine. 2.5. Final answer for C. All right, and then let's take a look at D. So I think you probably have a sense of what this is going to look like now, having seen the others. Log base b of b, and then so I'm expanding first. I'm going to subtract, and then I got the square root of y, which very similar to what we saw before. Square root of y I could write as y to the power of 1/2. When I expand, the 1/2 as the exponent moves this multiplication to the front. base b of y. Okay, this one, sorry, I'm starting at the end. That one is 12. So I'm going to have to multiply the 12 by a half. That gets subtracted from this guy. And log base b of b is 1. All right. 1 minus a half times 12 is 6. So 1 minus 6, -5. Final answer for D. Okay. One last thing that may show up in the assignment, you want to pay attention. We went over this in passing the other day, but you remember something from like 3 days ago that I talked about for like 5 seconds. All right, so we just saw log base b of b. If these are the same, then that equals 1, because b raised to the power of 1 gives you b, and so this equals 1. But what if it, sorry, wrong letter. Log base b of 0. Well, that's a good question. Let's actually write a couple of problems up here while we're writing stuff. These are the only ones that are going to, it's not like you're going to have any numbers. I mean, it's not a matter of like, this could be any possible number out there. There's only a couple numbers it can be. These are the only ones that could possibly show up. Okay, so let's think about these. What does an exponent mean? Well, sorry, what does a logarithm mean? So log base b of 0, that means b raised to some power needs to give us an answer of 0. What exponent can you put on a b that gives you a 0? Well, I know what people want to say. People want to say that the exponent is 0, but that's actually not true. It's not true. There is no way to get an answer of 0 if you have an exponent. So this one is undefined, does not exist. Log base b of 0 is undefined, just like that exponent is undefined. Okay, what about this last one down here, log base b of 1? Well, what does that mean? That means b raised to some exponent needs to equal 1. Can I put an exponent on b that would give me an answer of 1? I can. This is where we get 0. I know people want to put the 0 on that middle one, the log base b of 0. That's not where 0 shows up. Anything to the power of 0 equals 1. It doesn't matter what the base is. Anything to the power of 0 equals 1. So log base b of 1 equals 0. Right. That might show up in the assignment, and it might not. It might show up later. Who knows?